The pathway of sound by air conduction begins as acoustic energy when sound waves are gathered by the pinna and funneled through the external auditory canal to the tympanic membrane. This acoustic energy then turns into mechanical energy when the sound waves hit the tympanic membrane and set it into vibration. The vibration of the tympanic membrane then causes the middle ear bones, which are the malleus, incus, and the stapes to also vibrate. At the foot of the stapes is the oval window of the cochlea, which rocks back and forth with these vibrations. And as the oval window rocks back and forth, it causes waves in the cochlear fluid, which turn the mechanical energy into hydraulic energy. The wave of hydraulic energy travels through the cochlear fluids and bounces off of the round window right here. And there are two types of cochlear fluids, which are perilymph, located in both the scala vestibuli and the scala tympani, and endolymph, which is located in the scala media. And also located in the scala media is the organ of Corti, which you can see a close-up of right here. And this organ of Corti sits on top of the basilar membrane. And so as the hydraulic wave travels through the cochlear fluids, it sets the basilar membrane into motion, which causes the tectorial membrane up here to twist the stereocilia, which are right here. The stereocilia are embedded on top of the inner and outer hair cells. And so when the tectorial membrane pushes against the stereocilia, this causes the hair cells to open up and be exposed to both the perilymph and the endolymph, which creates a chemical interaction due to the high sodium, low potassium concentration in the perilymph and the high potassium, low sodium concentration in the endolymph. This chemical reaction creates an electrical current called an action potential, which goes through the auditory nerve fibers and up to the brain, and that's when we hear the sound. The pathway through bone conduction. In bone conduction, vibrations are transmitted directly into the skull, bypassing both the outer and middle ear and going straight to the inner ear. So in bone conduction, there is no acoustic energy. The pathway of bone conduction begins with the mechanical energy of the vibrations transmitted through the skull and then turns directly into hydraulic energy when these vibrations reach the cochlea. From here onward, the pathway of sound through bone conduction is the same as with air conduction, which is that the wave of hydraulic energy travels through the cochlear fluids and bounces off of the round window. The hydraulic wave travels, which causes the tectorial membrane to twist the stereocilia that are embedded on top of the inner and outer hair cells right here. And the hair cells then open up and are exposed to both the perilymph and endolymph, which creates a chemical interaction. And this chemical reaction creates an electrical current called an action potential, which goes through the auditory nerve fibers and up to the brain.